Hello, Chip GT here, and in this video I figured it was time that I kind of showed you how I do some modeling in Fusion 360. I've already started working on the back box here. You can see that I've already modeled a few components that are going to go into this back box to make it look like a Stern cabinet, and I've already modeled out some hinges so you can see how that operation works. We actually need to model this plate right here. So in the bottom right hand corner of the screen, we're going to model out, this is the outermost mounting bracket jacket of the Buki screen. And I'm going to completely 3D model this so that we know exactly how it'll fit on the back side of the panel here so that we can create some 3D printed parts. So real quick, I'm just going to turn off a lot of things that we already have on so I can better explain that. No, we need that. So what I'm trying to get at here is we have our speaker plate here. This right here is the speaker plate. And you see how it's kind of floating in air? That is about where it needs to float in order to make a joining bracket here on these pins. So these pins are actually threaded. I didn't thread them to free up some resources on the computer. But then in between, where this gap is, in between that standoff here, is where we're going to make a light panel. So here I 3D printed a prototype that this prototype worked out okay, but it was for a completely deframed monitor, so I did not take into consideration this frame. So this won't work because I've decided that we need to use this frame because all the electronics will mount here. And then there's even enough room. I could make a 3D printed bracket right here, and we could mount the audio control panel to the back of this jacket, and it frees up some space inside the cabinet. So this is essentially what it'll look like. And on the inside of the lip here, we'll run a ribbon of RGB so that way we can get some lighting on our speaker. And we're going to make it the same size as the speaker panel so it can mount right to that. And then this will go into this piece, and it'll have the ability to slide and lock the screen in place. And we're going to have to cut down this flange as well. But today we are just going to model this piece. So stay tuned and get ready to see some cool Fusion 360 at work. So something about this back box, I'm using best guesses here from what I have found online. If any of you out there actually have a Stern cabinet, it would be really helpful to me if I could find out what the dimensions of these side plates are from like edge to edge and then edge to edge here. That would be tremendously helpful because, like I said, the plans that I found online, they were for Ghostbusters. Ghostbusters doesn't use this full screen DMD. So if you guys have a modern Stern with a full screen DMD and you can get me those dimensions, I would really appreciate it. All right, from here, I'm going to change the view back to this view so you can see me and you can see the table, because I'm going to be going back and forth and referencing this component a lot. And I'm going to try to explain everything that I'm doing so that you have a better idea of what I am actually doing. But once again, we're going to click on the back box. We're going to hit new component. We're just going to call this the 15-inch monitor mount. There, it created it for us. Measurements here for this. So let's go ahead and measure that first. And I'm measuring it right at 8 millimeters. So in our sketch, we're going to select the line tool. We're going to do 8. And then we're going to come up. We're going to do the next measurement, which is up. Now this one does not have any inset or anything like that. I'm getting it at 212. Oops. So there's 212. And then we're going to come over 8 again. And now we're going to measure the full length. We're going to do a little mathematical formula here. So 362 is the total length. So we're going to go from here and do 362 divided by 2. And that gives us our half length, right? Here, I selected the wrong point. We'll do that again. So from here, from the point 8 or from the 8, we're going to go 362 divided by 2. If we can put this in parentheses to do a mathematical formula to make it easier for us. So 362 divided by 2 minus 8. And that's our length. And then we're going to come down the, what did I say? It was I think it was 162, or sorry, 212. 212. And then by process of elimination, we can come over and connect that. So now we have all of our dimensions. I'm going to clean it up just a little bit. So we'll take that out over here. There's that one. It's always good to put your dimensions on the outside a little bit because you want to be able to read it later on, or you may want to be able to read it later on. All right. So we'll finish that. And there's a reason why I didn't just do a rectangle. And that's because we're going to create a flange. So here's our flange. I want it to be on side 2, which is on the opposite side of the sketch. So sketch will be on top. We'll do a new body and we'll make sure it is aluminum, which will give us a 1 millimeter gap. Okay. So there we go. Now, okay. So now we're going to do our bends. So I'm going to select this side. And we're going to create a flange. And it says pick the sides. So we're going to do one there and this one as well, because they are going to be the same. It's just they're going to be lopped a little bit differently. All right. And as we look, I'm thinking that the original aluminum rule that I have is not correct. This looks much thicker. We'll change that here in just a minute. But first, let's go ahead. We want to make sure that it is, this is set correctly, that's set correctly, and our height is going to be 10 millimeters. So we want to make sure it's set to 10. There we go. Now, like I said, our aluminum rule, which you can't really see very well, I'm going to come over here. Our aluminum rule is not set correctly. It's set to aluminum millimeters. The standard for aluminum is 2. So I'm going to come over here and I'm going to change this rule. I've already set up another rule for aluminum with 1 millimeter. Click OK, and you see how that changed. Now we should be able to look at this and measure this gap here. This should be 1 millimeter, and that's 1 millimeter thick for a 2 millimeter bend. So, and if I click here, boom, 1 millimeter. So if you don't know how to do millimeter rules or aluminum rules and steel rules and things like that, there's plenty of resources out there and you can go from there. But just know that we now have this set correctly to the right thickness for 1 millimeter. And we did the top and bottom flange. You see how that's got the 1 millimeter. Now, this one right here is going to need a different rule. Because this one, or first actually, we need to make a couple of cuts. So let's come up here to the top. We'll do a new sketch from the top view. Sorry if I'm making you dizzy. So we'll start there. And we want to draw a box. Whoa, what the heck is going on here? Let's try this again. Sketch. There we go. Okay. So now we're going to create a box here. And this is a little bit of a lip that hangs over a little bit here. I'm going to switch the view so that you can actually see that. So here's the, come on, side cam. We'll cut without you guys being able to see it. I sure did. Anyway, I made a cut and we'll extrude it, and it's very similar to what I'm about to do. So we'll just do another sketch. We're going to start here at this corner and come over. And this one is 6. And rather than using a compass to try to get the angle, I'm just going to measure down. Measure that. That's right at 5. There's 5. Now we draw the line. There's our cut. Now with this one, we're going to take this one all the way across. So we're going to extrude, cut. I'm being a little sloppy here with it. So cut. There we go. And there's that flange. That flange is now done. All right. See how we're only doing half? We're going to mirror this. It's going to be awesome. It'll be really quick. We only have a few more flange pieces to do. So now we're going to grab this edge. We're going to create another flange. And there is our next bend. But this one is not going to be right. We're going to have to adjust this one's rules. Well, maybe we'll have to create a new rule. Because this one, I want to say it's like a 0.5 bend. It is not a 2 millimeter bend. It almost bends backwards a little bit, but yeah, that's like a 0.5 bend, not a 1 bend, but we know that it's going to be from outermost point to outermost point. That is 11. Makes sense because we're going to bend it back. So we will go ahead and we'll do 11. And then grab this edge, do our next flange out that way. And this one's going to be a long one. This one is 18. 18. So there's that flange. I want to say that one, this one is a 2 millimeter bend. So the only one we have to adjust is this bottom one here. And then we'll start working on our cuts to make this nice. So first, we will fix this bend because it is showing that it is a 1 millimeter bend there. So let's fix that. So how do we fix that? Well, we're going to just click on the feature, and then we're going to hit edit feature, override rules, bend override. So it's at a 1 millimeter on this inside here. We're going to change that to 0.5 because that's what I believe it is. It's a little bit tighter of a bend. So there you go. That is now set correctly. And then also this is bent more like it bends back further than 90 degrees. So we are going to go ahead and edit feature, and it's probably like a locking feature. We're just going to change it to like 91 degrees like that. And then this one will be bent back flat. So we'll edit this one, edit feature, and we'll edit it back 91. Make it nice and flat. So see how it's got like a little bit of an S now? That is what this looks like. Now, we're going to go ahead and start editing. this flange, because this flange has a bunch of holes in this. It doesn't look square. So we're going to go ahead and start doing that. First, we're going to lop off the edges. And this doesn't come all the way down, like it doesn't go all the way up, right? So that we need to cut some of this off on the upper part of the flange. All right. So first we're going to click on a sketch surface. Zoom out and we'll go, we're going to say this is the top. All right. So we want to make a nice box first, just looking at this. And we know that we need to go at a minimum of 18.5 across or 18.8. And then we need to come down. Measure that. 25 millimeters. So let's grab it and we'll do our cut. Make sure that I go all the way over to the edge, which I do not. So we need to edit this a little bit. Let's get our measurement here. Let's go ahead and make this like 19.2 and we'll delete the rest. That way it goes over just a hair. Yep, that's exactly what we want. Okay. Now we can click on finish. We'll grab our pieces of our sketch, extrude. We're going to extrude down 2 millimeters with a cut. There's that cut there. Now it jots out. So let's go back to our sketch. So now it jots out from the edge. So we know that this is a 2 millimeter bend. So we're going to just go ahead and include the 2 millimeter bend, and we need to come out 8. So we'll go 8. There's that line. And then we got to come down 10. So from here, we're going to come down 10. We're going to connect that line there. And then we're basically going to be tracing an outline now for this. So that's going to be a 90-degree angle. It's a 30 millimeter line. And we want to make sure that we keep everything nice and tidy and clean. We'll just put it right there. And now we're going to come down and over. So first we're going to go in. And this is a pretty long cut line here. So we're going to go in 8. And we're going to come down. Looks about like 6. And we'll connect those lines. And now we've got a long line. This is going to come all the way down, almost to the bottom, where we're going to mirror it again. And that is 110 long. See, almost all the way down. We're going to continue making a line. And I would imagine this is probably 8. No, it's more like 7 millimeters, and then we're going to come over. I imagine that this is take us right up to the outside edge again. Yep, right at 8. So just make sure my math is good and everything's going well. Yep, see, it went right there. Now we can connect those lines to get that angle. And then finally, we have one last little bit of a gap. And it is 6 and 5. So we're going to go from this corner over 6. And then from this corner up 5. And we'll connect those lines. And then that line. Okay, so now we have all of our pieces that we need to cut. Where'd the sketch go? There it is. So we want to select, I'm going to edit sketch, and we're going to select all the pieces that are going to be cuts. Okay. Cut. Finish. Extrude. 1 millimeter. Cut. Boom. So that is what that lipped flange now looks like. All right. So now we got some holes to cut. So let's go ahead and start doing that. The one side of the hole is in line with this, and then we have a hole and it's offset a little bit. So we're going to make a reference line first. So we're just going to come down all the way. So there's a reference line. And now we're going to measure from this inside piece here up to the center line of the hole. So let's see here. That is about 8. And then the width of the hole here is 5. So we're going to come over 2.5 and then make 5-inch circle. Oh, 13. It's 13. See, this is where you have reference points. So if I change that to 13, it brings that hole right back up in line. All right, now let's do the holes up here. .5 and 6. Okay, now we're done with the sketch. Now we can select, if I hold down the shift key, or not shift, but control. Now I can select all these things, get a little bit different view, extrude, and cut. See how it goes all the way through? This is kind of what we were looking for, but I like to keep it extruded to the actual piece that I'm working on. So we'll cut, and there's that. Now we're going to go to the side here, and now we're going to put these little side holes in right here. So we'll just click there. We'll start with this upper flange here. There's our cuts for that. So let's go ahead and we'll select everything for this, and we'll extrude in the holes. All right. Getting almost to the fun, cool, crazy part. So there's that one. And that one, and that one. Put it at an angle. Extrude. Can't even see the stupid arrow. There we go. And we will cut in by 1 millimeter. Boom. Uh-oh. Something's not right here. I did not grab. Still looks goofy as all get out, doesn't it? All right. I'm going to back up. I'm going to fix this. So I'm going to pause real quick. I'll fix it and then we'll come back. Okay, I'm back. So what ended up happening is I did not extrude when I cut this right here. I did not cut it down far enough. So that was the problem. It wasn't anything that I was doing with this particular piece or anything like that. It was this cut down. All right, so now we have all the holes, we have all the flanges. This is where it gets to be a lot of fun because remember how I said, you know, it's kind of a pain in the butt to model all of this and, you know, in one go. Now we're going to have some fun because now we're going to use a command called mirror. So we're going to mirror. We've already selected the object and now we just select the plane in which we're going to mirror on. And the plane is right here. So we're going to select the mirror plane. Boom. We're going to make sure that it says bodies and join. That way it becomes one piece. And it's going to sketch out the other half of us just like that. We didn't have to do all that extra work. It was awesome, right? So now we have the complete frame. Helps if I have it right here. So now we have the whole complete frame with the exception of the holes down here that we did not extrude. So let's fix that real quick. Okay, so down here in the bottom of the timeline here, we're just going to go backwards in time a little bit to where we extruded our holes, which was right here, right? And we're going to click on Edit Feature. Look, there's our holes we forgot to extrude. So now we're just going to hold down the Control key and include them in the cut. There they are. And now when we go forward in time, I'm just going to zoom out a little bit. Oh, we didn't do those holes up there either. So let's edit the feature again, zoom in, cut. We'll hold down the Control key while we're doing this, cut. Boom, there's our holes. There we go. Now, when we go forward in time, they're there. Pretty cool, right? That's why I like using Fusion 360, is it allows us to have that kind of versatility. Now, this is upside down. We're going to flip it because right now it is upside down when we compare it to that. So we'll come over here, flip it 180 degrees, done skis. Now we can see about, well, you know what? Let's get a good reference here. Let's get it in a vertical 90 or as close to 90 as we can, because this sits back a little bit. So I bet you it's, I want to say it's like 12 degrees or maybe it's 13, 14 is pretty close to a vertical. Actually, no, we need to do the holes on the backside before we do anything else. Let's go back to our top view, rotate. We'll zoom in, and now we're going to create a new sketch on the back, capture position. And it's measuring now from the inner part of the lip, and that's fine. We will just go with that for now. So let's do the big hole on the back. And from the innermost point of the lip, we are looking at 96 millimeters. That looks about right in the grand scheme of things. And then we're going to come up to the bottommost corner of the hole. That around. And that is 12 millimeters. And we'll make our box. First its height, which is 35. And then 45. So there's the electronics hole where the electronics come out. But I also want to do the mounting flanges that I might possibly use and create a 3D print for. So let's go ahead and we'll find the holes for this. And we're going to have to create standoffs on here because on this plate, these are actually standoffs and they're welded. You can see the weld marks on the inside of this. And what we're going to do is we're going to create the holes first. So we'll create the holes where the mounting holes go, and then we'll just copy and paste standoffs and attach them that way. So I know that these 4 holes are what we use for mounting the electronics panel. And that is at 37 over. 37 over, and then we're going to come down. Bet you it's square. I bet you it's 37 because it looks square. Actually, I was wrong. It's 36. So go 36 there. And remember how I said I was measuring from the outermost point? Well, from here, we're not measuring from the outermost point, and this flange here, if we remember correctly, is 1 millimeter or 2 millimeters. So in reality, this is going to be 34. And this one, which is also 36, is also going to be 34. So there's our first reference point. We'll make our hole, which is 4. It's going to be a 4 millimeter weld. So we'll just make a 4 millimeter hole. And then from here, we're going to reference all of our other holes. So we'll come down from center line. Cut through. There they are. And now we can use these as reference points for when we go to make the standoffs. So now, just very quickly, we are going to do this nice, quick, and dirty because this is getting really long. Let's see here. The standoff itself is about 5. And then the inside diameter is for a 3. So it's 3.5 hole. So it's a 3 millimeter hole. So it'll be 3.5. Whoop. 3.5. 0.5. And we'll select the outer ring. Finish. Extrude. This is going to be a new component, or no, we'll make it a new body, and then we'll extrude it up. Say they were 10, 8. They are 8. This is why we measure twice, cut once. Okay, now this body should be right here, and we're going to create. We're going to create, I think we have to make it a component. So make it a component, which sucks. And we'll rename it standoff. We'll call it 15-inch mount standoff. Okay. So remember how I said we have to weld it? Well, even in this program, like this is one body, this is another body, we have to connect them together. We have to assemble them. But first, I need to make a whole bunch of these guys. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to create 10 of these guys. So copy, and then we're going to paste new. So it's its own separate thing. So there's 1. All right, Now we're back to normal motion. Now we've got to connect them. And the way you connect them is really stupid simple. So we're just going to make a joint. We're going to click on the center of that circle. Then we come over and we select the center of that circle. Boom, they're joined. It's that simple. I'm going to do that a whole bunch more, and I'll either fast forward or I'll cut it, and we'll be back. Okay, we are back. Now, I've got these really ugly, I got everything modeled that I wanted to, and I don't know, in reality, there's really only like 4 more of those standoffs that I did not model on here, but I'm not planning on using them, so I don't care. Now we're ready to bump this up and see how exactly it's going to fit on here, and how much of these lips that we're going to have to, you know, cut off using a Dremel tool, I think is what I'll use, because I really need some fine cut movements, but I want to leave a little bit of a lip so that when we go to 3D design the sides for the speaker panels, that we're good to go. But first, I want to get rid of these ugly joints. I mean, some of them are good for seeing, but I'm just going to click on these joints to make them go away. We know that they're attached. I don't need to see them anymore. And now when we go to move this entire component, everything will move with it when we go to rotate it. So let's go ahead and we'll rotate it up to about the 90-degree position. And then I'm going to move this so that you can actually see it for once. I'm actually doing this now. So we'll come up, we'll come over, and on here, this is going to sit right up against the glass. So there's like a piece of glass here. Let's actually look at it from this point of view. So you can see this is a glass panel here, and this needs to sit right up on that glass. So we will trying to think the best way to do this. So what I was concerned about is this flange is actually out further than, oh, there we go. Now we can see it. So we want this to kind of mate up to that. I'm going to move the move point to here. That way we can kind of see how it's going in. There you go. That's pretty flush with where the glass is going to be. Now let's check the other side and see how that looks. Yeah, see, this side is not quite centered. So we'll just move it around to the front. Lining up is always kind of hard when you're eyeballing it because we don't have a mount hole reference point for this. So this is what is going to be just a little bit difficult, is just getting this somewhat centered. Let's go with 7. Okay, 8.5. So we're 8.5. I mean, that looks pretty close. I think that's gonna do it for now. Because we've got a 3D print. So this is where I was talking about. So we got a 3D print an interface that will go onto these slots and plug into these holes right here. These teeny tiny little guys right there. And one right here. That, or we're going to have to make a cradle that'll cradle the bottom here and then the top here. All right. So I think this is a good cutting point for this video. And we'll make this, I'm going to call it a cradle, if you will. We'll try with a cradle approach first to kind of cradle it, because these holes are so small. Those screws are so tiny. That's a lot of weight to put on such a tiny screw in a piece of plastic that we're going to 3D print. But what we now know is we need to cut these things down to get rid of those holes. Like, we got to cut this flange almost all the way down in order to get that to fit right. And then if you look down here, you know, we're going to have some overlap on the spacer, so we might have to cut the spacer down, maybe not, I don't know. Just trying to get an idea here. Yeah, Yeah, I think we're gonna have to. Well, the spacers are 2. So the glass itself is 2 millimeters. This is 2 millimeters. So we're gonna have a really wonky, really kind of crazy piece here. It's gonna be fun to design, and then we're probably gonna have to do several test fits. Oops, I did not mean to do that. Go back. There we go. And I'm gonna leave this just like this for now, so that we can work on that in the next video. So that's next. Now that we've got the bulk pieces designed, now we can start working on our 3D printed component. That's going to be our interface between a Spooky and the Stern Backbox. And we now know that we need to cut this thing. We need to cut this lip way down, like way down. So that'll be the next video. We're going to cut this down and we're going to start working on 3D printing this part. So thank you everyone for watching, and I'll see you next time.